Unit 3 Electromagnetic Induction. Introduction. Whenever magnetic lines of force are cut by a closed circuit, an induced current flows in the circuit. And this current will last only as long as the change lasts. This phenomenon is called electromagnetic induction. Now, the experiments performed by Faraday. This is a coil of wire. The two ends are connected to a galvanometer. There is a magnet. It is brought towards the coil of wire as seen in the figure. Now, it is seen that the galvanometer deflects. A galvanometer will deflect only if current is there. As you see in the figure, there is no battery. Still, the galvanometer is deflecting. It means that the magnet which is coming closer to this wire, due to the movement of this magnetic lines of force are being cut by this wire or coil, and because of that there is an induced current, because of which the galvanometer deflects. It was also observed that if the magnet is taken away, the galvanometer deflected in the opposite direction. That is, still there is an induced current, but in the opposite direction. So, the first experiment denotes that whenever there is magnetic flux linked with a coil changing. Now, why is the magnetic flux changing? The magnet is moving. So, as long as the motion is there, either towards the coil or away from the coil, the galvanometer deflects, that is, there is induced current. Then another experiment also was performed, experiment number 2 by Faraday, which was like this. This is a battery, primary of a coil, connected to a key. Key is nothing but a switch, on off switch. Now current will flow only through this wire. Now close to this wire P, another wire was kept, secondary, which was connected to a galvanometer. It was seen that the galvanometer deflected whenever the key was closed or open. That is, when you switch on and off, the galvanometer deflected in opposite directions. So, as long as the change is there, that is, switch on one direction, switch off another direction, there is an induced current in the secondary of the circuit. Now, when will there be an induced voltage or current? It can be due to relative motion between magnet and circuit. Second, it can be by a change of current with time in the same circuit, as I told you, switch on, switch off, or by a change of current with time in the neighboring circuit, or by rotating a coil in a magnetic field, or by the motion of a coil in a non-uniform magnetic field. Because of any of these, there will be a change in magnetic flux. And whenever there is a change in magnetic flux, there will be an induced EMF, due to which there will be an induced current. Now, Faraday's laws of electromagnetic induction. The first law: whenever the magnetic flux linked with the circuit is changed, an EMF is induced. Phi B is a magnetic flux. Rate of change of magnetic flux, d phi by dt. This will give you an induced EMF E. That is the first one. The second one: the magnitude of the induced EMF is directly proportional to the negative rate of variation of the magnetic flux linked with the circuit. How much of EMF? Minus d phi b by dt. What is d phi b by dt? Rate of change of magnetic flux. That is how much the magnetic flux is being cut. If there are n turns in the coil, E is equal to minus n d phi b by dt. So these are the two laws of Faraday. State Faraday's laws, so you have to write these two. Now, the same Faraday's laws can be expressed in integral form and differential form. Now, integral form. The magnetic flux around any conductor, if there is a closed surface, magnetic flux phi b is integral b dot ds. Now, the voltage or EMF induced in the closed circuit will be E dot dl, where E is the electric field, dl is the length of the element considered. Now, equating integral E dot dl is d by dt of b dot ds. From equation 1 we get that integral E dl is equal to d by dt of integral b dot ds. This is the integral form of Faraday's law. Now the differential form. E dot dl can be written as del cross E dot ds by Stokes' theorem. Now del cross E dot ds can be written this way: d by dt of b dot ds. Why? Because E dot dl is b dot ds. Substituting that. Or del cross E dot ds is this d by dt taken inside dou b by dou t dot ds. Comparing the two, del cross E is dou b by dou t. Or we can, del cross E is nothing but curl E. It is dou b by dou t. This is the differential form of Faraday's law. So, integral form, this is the integral form, this is the differential.